Hope you all are having a good one. I basically am wrapping up on another course that I've taken, and I've got a couple of videos on my backlog to do, which basically reflect on the things that I've learned, as well as to give a recommendation to another course. On this one, I'm going to try my very, very best because I know time is very valuable to others, but I'm trying my very, very best to make this as quick as possible. Basically, for the last, I would say 15 years, I've been doing .NET C Sharp. I don't want to say that's all I've been doing, but primarily the main actual object-oriented language, if you will, has been C Sharp and .NET. Before then, for a period of 6 years, I did Java programming from 98 to 2004, working with various frameworks like JSP, Servlets, Spring, not Spring, I meant Swing. And recently, in the last, I would say 2 years, academically and because I have a passion for it, I've been doing an awful lot of learning and research and trying things out, and actually doing deep dives into microservices, domain-driven design, as well as containers and orchestrations, and just how to get better at that. And I've been continuing to get better. Sagas are a very important concept in microservices, and all too often I feel that they're a concept that's been kind of difficult at times to grasp around. And in order to do sagas, you just have to get your hands, basically your hands and feet wet. There's not that many courses out there that really go into dives and such. So along the way, I practiced with sagas and another application that I was kind of toying around with. But along the way, I found this course right here, and they actually have a section, or this author actually has a section on sagas. I also noticed it was in Java, Spring Boot. So I thought, well, it had been a while since I had done some Java programming. I think I remember much of it. I pretty much transitioned over to .NET and C Sharp before Spring actually became a thing. At the time, it was J2EE with Enterprise Java Beans, that sort of stuff. So I thought I would just go ahead and take this course and try it out and see what I've got to, see what I got to lose, because there's a section there on sagas. And so this is kind of like my perspective on this as a .NET C Sharp programmer. So not really knowing all that much at all about Java Spring. I mean, I do know what Spring is, and with .NET Core, we do a lot with the dependency injection and injecting services into constructors and using those types of patterns, but never really formally worked with Spring. So I really wasn't sure what I was getting myself into. So I bought the course and I started, taking it and trying to see if I needed to take the prerequisites or not. So, and I'm here to kind of tell you, in order to take this course, and it's an excellent course, you'll need JDK, JDK 11. You'll need an IDE. Now, the author uses IntelliJ, which I absolutely love. I used IntelliJ back in my days when I was doing Java, and they've changed a lot with IntelliJ. And as you're looking at the IntelliJ interface right here, one of the nice things about this course, if you do choose to, take it, you're going to learn quite a bit about microservices and a lot of the really cool things that come along with Spring Boot. And the title of the course is Cloud Beginner, Spring Cloud Beginner to Guru. Honestly, having finished this course now, except for the last section, and I'll get into that real quickly, that was a conscious decision on my part not to do the very, very last chapter, and I'll tell you why in a second. But I wouldn't consider myself a guru in the least. I mean, as a matter of fact, I went through all of the lectures, the videos. I tried things. I typed everything in. I tried and I explored with various things like what happens if you change this or change that. Another really cool thing about this course is he gives you assignments, and assignments are a good way to get practical hands-on experience, and then you can actually submit your labs at the end of it. So you actually get to do quite a bit of hands-on. But would I consider myself a guru? No way. Um, Basically, having finished this course, I would literally say at this point, I know enough, I would say, about Spring applications in Java to be able to go into existing code that somebody else had written, or to, undertake a task of converting some apps in other languages or even Java, and smaller ones, or to intermediate sized ones, and start incorporating Spring. But there's quite a bit of learning to do with Spring. Now, I got to tell you, I took this course, bought it about a month ago, and it's a very, very aggressive schedule. I would say probably in the last up to a month, 3.5, 4 weeks, I probably spent a good part of 100 to 120 hours on this outside of work. I don't watch TV, so I do a lot of my learning, training, things of that nature in the morning and in the evenings. And I still am able to maintain a little bit of a social life and other things on top of my full-time job. So let's just kind of get into, these sections here. If you're a C#.NET programmer who's never used Java or programmed in Java before, this course may be a bit of a struggle, and this author, John Thompson, has other courses to take. So if you've done Java before and you've moved over into .NET, but you've never done Spring before, I can pretty much say you can take this course without taking a Spring course, but keep in mind there are going to be annotations, things of that nature that you're going to, stop, pause video, do some research and look and say, hey, and what is that about? And why is that? But on the face of it, the code makes a lot of sense. Now, granted, without understanding a lot of the annotations in detail, some of the sessions that I've had to debug, some of the things didn't start up properly or whatever. It took a little bit of time, but hey, that's always a good learning experience. So going through the course here, this is really what stood out as why I was really interested, because there was almost a 2-hour section with sagas. And it's not that, I would want to do Saga just with Spring, because I want to apply that to either Python or .NET or whatever language potential employer company would need me to work on and work in. And there's integration testing using, JUnit. And I really learned a lot. And they talk about compensating transactions with sagas, which is really, really important. And I haven't really gotten into what a saga is. And of course, this course is container driven. So, you build the microservice, you start with the monolith application, it gets decomposed from the monolith into the different microservices. And then incrementally, he introduces newer and newer features into it, which is really cool. And then completes the course by Dockerizing and containerizing everything that you've learned, including a section on Elk Stack. Now, this is the part that I did not do, and I chose conscientiously not to do Docker Swarm. I've really been, on a Kubernetes kick almost for the last year and a half. I've taken all kinds of courses, and Kubernetes for me is like really what I'm pretty much focused on when it comes to container orchestration. Nothing against Docker Swarm. It's just another type of an orchestration mechanism that at this point in time, when my sole purpose was, to learn and do more hands-on with sagas to try to really get a firm grasp of them, I found this course useful. But I just didn't want to go through the Docker Swarm part about it. I mean, it's, I'll get back to that at a later time, but there's so many other things that I need and wanted to learn first. So having said that, if you sign up for the course, the instructor will give you a 4-month license for IntelliJ, which is really, really nice. And that's what I'm looking at here is the latest and greatest IntelliJ. So you'll get that. The course, I would highly recommend that you use IntelliJ. You can use Eclipse if you want, but in a lot of the videos, the instructor does an awful lot of refactoring, shortcuts, keys, and utilities using IntelliJ. So if you're not using IntelliJ, I would highly recommend, because if you're using Eclipse and you have to install other plugins or whatever, you're going to probably spend quite a bit of time, taking what he did with his IntelliJ and doing all the project settings, things of that nature for each of the individual microservices. And you're going to have to, do the equivalent inside of Eclipse. So do keep that in mind, basically. I would also like to mention that I did get approval from the instructor and the instructor's aide to do this video, so I can show you some of the code. As a matter of fact, you can find his code out there in GitHub. If you just do a search for MSSC beer inventory service and some of these, you'll see his repository. Now, I didn't, just clone his repository and just follow along with the videos. I actually started from scratch. I started with the, creating the projects from scratch and spending the necessary time basically going through all of the videos, typing, pausing, and then trying different things out, right here. So what he does in this application, he's got a fun application. I would literally say it is fun. And it's what I'm showing you here. This is some of the resources. It's basically, he created a brewery, starts out as a monolith application. But the long and short of it is, in his architecture, if I can get to it right here, I did kind of want to show you a little bit. You've got this fictitious brewery, and this brewery actually brews beer, and then you actually have, it's like a beer distributorship, and then you have a pub, and basically, so you start out with the pub, and it's a warehouse type of a delivery system that has a distributor, but the pubs become kind of like the customer, and in each of the pubs or in the pub itself, they'll create beer tasting. And what they end up doing is creating orders, through the pub, through the consumer, via the pub. It creates orders, and the orders themselves, get to the distributor, and the distributor, if they have quantity on hand, they're going to go ahead and package it up, potentially deliver it back to the pub and the consumer again. If they're missing quantity in hand, they're actually going to ask their brewery to brew more beer and then supply the beer back to the distributor. So it starts out with a monolith, and then as you go along through the course, he breaks down reasons and different techniques on how to deconstruct that monolith into separate microservices. So, you'll have like a beer service, which is, for the consumer. You'll have the pub that the consumer is inside of, tasting the beer, all that kind of stuff. You'll have the distributor, which is actually, the warehouse that services the pub with all the inventory and the products. I used to work for Anheuser-Busch, so, I worked on one of their warehouse distributorship systems. So it's very similar to that. And then you'll actually have the brewery itself, which manufactures, brews all the beer and sends it out to all the different distributors, which turns it around into, sending it to the pubs and then eventually into the bellies of the customer. So having said that, as you go along the way, he's going to walk you through, what the microservices are. Now, I know what the microservices are, but every course I take, I always like to get a different author's perspective on it, because every single time I seem to learn more and more, which is really good. And then basically, he goes through an overview of the REST services in Spring. So there's a lot going on here. And I was just kind of amazed at how much I learned as I went through the course. I'm very familiar with .NET, REST API, controllers, things of that nature. So I was very curious from a Java perspective, just to see what some of the equivalents would look like when it came to controllers. And as you can see, as you go along, he's going to, walk with you, and you're just basically going to be building up, these different particular controllers and 8 REST endpoints, things of that nature. So I'm going to show you that a little bit more, but I'm not going to go into too much detail because I'd really encourage you guys to take the course. If you're a Java programmer and you know Spring, this is a great course. You know way more about Spring than I do, although I wouldn't mind getting a Java job doing Spring and the opportunity to get better in it. You'll learn about, Spring Boot REST template, what that's all about, how to validate your beans and all of the data that you're sending back to your controllers. Another really cool thing was Project Lombok. And this is kind of where he gets into, somebody that's somewhat new to Java Spring like myself. He explains a little bit, not a little, he explains quite a bit about Project Lombok and, how these annotations themselves, basically are pulled in and analyzed and evaluated, basically. One of the things, one of the big takeaways that I've got from this course, after completing it, here you're looking at an API for the beer order service. One of the big takeaways in what makes Spring, really cool, and it's similar to .NET Core, but I mean, you have a lot of decorators, basically, just like in .NET Core, how you can actually use filters and annotations at the top of your controllers, and behind the scenes, they're basically pulling in and executing more code, particularly, authorization and validation filters in your controllers and stuff. It's kind of what Project Lombok does, with a lot of your annotations here. But as you can see, this class here, there's an awful lot going on in this customer controller. This GET mapping is pretty much from a .NET standpoint, it's the same thing as an HTTP GET, but behind the scenes, just by the sheer nature of that particular annotation, you're getting all these freebies for the most part, that come in. So there's a lot of ways to customize your behavior. It's kind of like, my takeaway is you opt into a whole bunch of things with Spring, and then you set up, using dependency injection. It's really kind of cool. You set up some of these, shall we say, variables or private properties and stuff that will automatically get injected through your constructors and stuff like that based on some of your annotations. Now, I got to be honest with you. I mean, you can see these decorators. There's mappers, which allow you to do automatic conversions with these interfaces. So, based on, I won't get into great detail on what the mappers are, but you basically are extending behavior of your classes by utilizing some of these things. Now, here's one of the gotchas, or one of the things you might have a little bit of a difficulty if you're not too familiar with Spring or you're not familiar with it at all. When you look at a piece of code like this, it's not going to be intuitively obvious. You're going to see this beer service coming in. So I like the patterns that the instructor is using in this course, but you're going to see this beer service coming in. And then later on down here, when you get the list of beers and all that, you're going to be like, well, how does that get initialized? Well, it's like .NET Core. It gets dependency injected, but the way that happens, like whereas with .NET Core, in your startup.cs and your configure services and all that, you'll set up all of your singletons and your transient, scope services and things of that nature with service calls, and then you'll just declare a constructor that takes, you basically define what you need. With Spring Boot and all that, it's very similar, but you've got these annotations like, Project Lombok. It's what's so wonderful about this project. It's required args a constructor, and there's a whole bunch of annotations. But when you decorate your class with these, what you end up with is, behind the scenes, it basically is going to take all of your private final classes or your arguments there, and then it's going to behind the scenes generate a constructor for you that takes this in, right at like compile time and all that, so that your code here will work just fine. So another beautiful thing about IntelliJ, which is why I highly recommend that you use it, it's just the number of features is just amazing. but you can click on that right there, and then it says, basically generates a constructor with required arguments. And, so it's the final fields and then fields with constraints here. So I'm not going to really go into detail, on what that's all about. I'm just kind of letting you know that Spring is heavy, heavy, heavy on the annotations. And then there's this is similar to almost like a from body annotation with .NET controllers, or a from URI. In this case, this is a from URI. It's very similar to that, when you're decorating a controller method. So basically pulls it out of the request string. But let me see here. The other thing about this course is they use Maven to do your build, your build and compiles. And IntelliJ has really nice Maven features right here. As you can see, these are the services that you're going to build out, that we had talked about. So you're going to have the inventory, the order. You're going to have the regular beer service, and you're going to have, the beer service is like the brewery per se, if you will. And then you're going to have this failover. It's another really cool thing. That's where he goes through the circuit breaker pattern, which I really love too. So with these plugins or with these extensions on the side here, you can do an awful lot. So you can actually, clean your code, validate it. You can package each of your services up into a local repository on your machine. And talking about a Java repository, as well as caching. And some of these right here, some of these targets, it's similar to Ant, basically, or Gulp, where you have Gulp tasks in the past, or Webpack itself. Very, very similar. The other thing too is at any given time in each one of these services, you can see the different dependencies that you're pulling in. So he actually does a really good job of discussing Maven. And the other thing that I've found really cool, so you're going to get an awful lot of freebies with this course. And what I mean by freebies, you're going to learn Lombok and MapStruct. And MapStruct, basically, long and short of it, is a way to, adapt, if you will, via adapter pattern per se, where, you'll have your controllers expose to your clients data transfer objects. And those data transfer objects are going to be those solidified contracts back to your client. Technically, they shouldn't change, or they should change very rarely, if at all. Instead, you probably want to create a new version. What changes behind the scenes will be your actual models themselves, and your models will be reflective of your database. And that's another thing I hadn't shown yet, which I will. But MapStruct is basically a way of mapping the data from your DTOs that you're passing, to your clients, mapping it to your model objects and vice versa. So it's kind of like a to and from, and then a from and to. So he's going to show you a little bit about how that works. And so how that's done is, you'll create a series of mapper classes that'll, basically identify or give you the functionality to do that forward and backwards translations between your model objects, which are servicing your repos, your repositories, to your clients out there, and the rest, which are, basically your data transfer objects. So here's an example of a mapper, and you'll create many of these. But if you look up here, as you can see, you've got MapStruct. So that's kind of what MapStruct is in a way. You're kind of specifying, what you're returning and what you're taking in, and MapStruct is going to kind of help do the rest. And then all of a sudden, you use the builder pattern as well. That's with Lombok, but you're going to have it's kind of like, using the JavaX persistence classes, Hibernate, things of that nature. It's very similar to Entity Framework, where you can decorate and annotate your attributes and stuff like that. As you can see right here, you specify, these are your entity objects, and you can specify, the different, shall we say, behaviors and characteristics, more or less characteristics, not behaviors, that each of your properties are going to have. and then behind the scenes using JPA and things of that nature, it's going to translate into real world database tables as well as properties. Speaking of which, you know, the whole concept about microservices is taking your monolith and deconstructing it, and each of your microservices is going to have its own database. So in this given example, or this application, you're going to have several different databases. You know, it's been broken out and from one monolith into, you know, a beer service, an order service, and an inventory service database. So you're going to have a database for each one of these, and your microservices themselves, each individual microservice is going to be responsible for its own database. So that's, you know, the desired state of microservices. You don't want to have, you know, more than one microservice that crosses bounded contexts, you know, accessing the same database per se. Now, others would argue it's okay to have them access the same, you know, instance of SQL Server or MySQL, Aurora, or Oracle. I mean, that's okay as long as there's a clear division from the databases themselves, because the whole, you know, one of the advantages of microservices themselves is they're independent from one another and they're independently deployable, and you'll have, you know, technically two pizza teams working on them, granted, and you know, you want to be able to deploy independently of the other services. And if you don't want one microservices database changes to stomp on another one as far as deployment's concerned. So you're going to use MySQL. And as you can see here, we've got the 3 different databases. We've got, you know, the beer inventory database right here. We've got in the beer order service, we've got these different tables inside of there. And again, this is using MySQL, but you could use pretty much any one you want. And the other really cool thing about this course is based on, you know, you can configure it using JPA and stuff like that. And it's all done. It's really, a lot of it is done again with Spring here with the annotations. There are configurations too, where you can specify. If I go down and show you these resources here, you have several different resources that can get loaded depending on the profile of your individual project. So each of your projects themselves, you know, you define different profiles, which are kind of like identities for how you're going to run that given project per se. So what I mean by that basically is you can, you know, edit your configurations for the given projects themselves. So, or microservices, that's kind of what I like to call them right now. But based on, you know, which ones you're actually going to be selecting here, you know, these are your individual services. When you click on these, again, you know, IntelliJ makes this really nice. You know, we'll talk about the beer service one. If you scroll down here, you can see these active profiles. So this is actually what I mean by profiles. As I'm clicking on these, you can set these while you're developing. You can also specify them at runtime, and in your containers, you tell it which profile. The beauty of that is you can do all of your development against a in-memory H2 database, you know, which is really, really nice. And you can toggle that and switch it back to using, you know, local MySQL. And there's also this discovery service. But based on the profile that you choose, what you end up with is, if you look here, like in each individual project, you go into your resources, you're going to see like these different properties for each of these individual profiles. And so the naming convention, Spring is all about naming conventions here. You'll see application-local discovery, you'll see application-local MySQL properties, and then you'll see the default, and you can override these. So it's very much in like .NET, where you can have, in .NET Core, you can have like application JSON and an application prod.json, which will override anything in the global, and so on and so on. Same concept here. so if we take a look at the local MySQL, so this is, basically what happens when you're running in, when you're using your local MySQL service here. So you've got all these different properties and annotations. So this is where we're actually hitting my own particular local MySQL, which is right here. I'm not going to go into detail. I'm just giving you a high level, fire hose right here. And then, that would be right there. And then if you're using the regular H2, if you don't use the local discovery, let's just say you want to work and do unit tests. So when you're running your unit tests or your integration tests, typically they tend to use these instead. So that's where you can actually, in your setup and teardown, you can drop and recreate your tables. And then you've got this in-memory database, very much like with Entity Framework, in .NET. But the schemas are identical. The entity classes are identical. So, like I said, your DTOs and your model objects are pretty much going to be the same, whether depending on which profile that you're using. Now, another thing that I think is really cool, I kind of paused the video a little bit there. I had Docker running, Docker for desktop. By the way, this course is going to assume that you have Docker installed, and you should know enough about Docker to be able to, navigate and get around with basic Docker commands and things of that nature. But I have 16 gigabytes of RAM on my machine, so whenever I start up my Docker for desktop or what have you, my machine tends to run a little bit more sluggish. It's time for a new computer. But basically, what I wanted to show you here, and I went ahead and saved some time. What's really cool, I'm not going to run this in Docker just yet. There's a services tab down here too. And right now I've got all these applications running, applications like services themselves. It takes a couple minutes to start them up here, but each one of these services that you see here on the side, for the most part, you can see right here we're starting them up individually. And if you look here, it may not be intuitively obvious, but as I click on each and every one of these, you can see this side here changes. So really, it's showing you the logs for each of those services. So they're all running independently of one another. But this is really what I wanted to kind of show you, which is really nice. This application is using service discovery through, a well-known service discovery, shall we say, paradigm? I don't know what you would call it, API or whatever. It's called Eureka. And it's, another component of Spring. But here, as you start up these individual services, they come online. So you got to start up Eureka first. And basically that's like a service and registration thing. It's another key component of microservices, service and discovery. So basically behind the scenes, the whole concept with microservices, especially when they're scaling up and down, IP addresses, things of that nature, locations themselves may change, but the names of the services won't. And you can register a lot of these services, not a lot, but all of them, if you will, as an application. So behind the scenes, as they're switching physically to different sources or machines, environments, or whatever, all your other services here can see them, as they are by their names. So, for example, let me just show you what would happen if I stop so I've got this inventory failover, which is our circuit breaker. I can actually go here and stop. So this is a really nice feature inside of IntelliJ, and I'm sure Eclipse has this too. I never was really comfortable with Eclipse, but with IntelliJ, is fairly comfortable with IntelliJ. So here I basically stopped that service. And now if I refresh, this inventory failover service shouldn't, let's see what we've got here. Oh, that's interesting. It's still showing up here. Okay, I was wrong actually. As the applications or services register themselves with the name server or the service discovery right here, If the application itself should die, it's not deregistering. I'm sure there's probably a way to deregister a service when it shuts down, to deregister it here, but in this particular case, I didn't actually do that portion, and the course didn't get into that. But I'm suspecting, and somebody can correct me if I'm wrong out there who really knows Spring inside and out and how this works. I'm suspecting there's a way to deregister yourself, but that's, one of the things that's like a to-do, a future thing. It might be a future fun project. But as I bring these things up, another nice thing is, you can actually debug. And so you can set breakpoints in your individual services. Again, the failover, it's basically your circuit breaker. It's your fallback service that, one of the principles of microservices is things can fail, come in and out of service and scope. And instead of failing the whole system, you can just basically have a placeholder, and then the circuit breaker can be configured to redirect traffic to the placeholder. That's kind of what this is. And so you can, it all depends on your application itself. But I'll just go ahead and start this up here. And as you can see, it's going to build, and it's going to actually start this application up again. Now, I can assure you, if I stop all of these here, and I went back to my Eureka, once I restarted everything, this application list right here would be empty because the applications themselves haven't registered themselves with the service right here. So ideally, I guess the thing that you'd probably want to do is have your failovers running, so that if you bring some of these services up and down, or they should crash or whatever, have it configured with the circuit breaker pattern to go ahead and route traffic over to the other failover services in that case. Let's kind of take a look at that real quick on how you would, how the whole circuit breaker thing works, at least in this application. This application does work. I'm looking at Postman here, so I save you the time of bringing that up. But basically, I'll get to the failover in a second. But as you can see right here, I've got all the services up and running on the left-hand side here. You can set breakpoints, you can debug your services, lots of stuff you can do here. But the long and short of it right now is you can call these right here with localhost 9090. Now that's 9090 is basically your gateway, and it's using the API gateway pattern of microservices, kind of like the facade, if you will, or the protector of all the backend services. And so some of the things you can do here is you can make a Postman call to get all the customers. So here's your tasting room, which is, basically these are your individual customers. It's a brewery. So, and then right here, you could take a look, grab this customer ID right there, and then you could say, well, I'd like to get the orders for that customer. So you could potentially see what happens right here if we paste in the orders for this customer. Let's see if I have any. And I just pasted that, hit the send, and yes, you can see I do have orders right here. So basically, we've gone, from the customer to the order service to grab, the different orders for that given customer. And also behind the scenes, it'll take a look at your quantity allocated, see what's been allocated and what's on hand. So the nice thing about that is that particular call itself is reaching out into the order service, which behind the scenes is making a call out to the inventory service if you wanted to show your inventory. So there's a lot going on. But getting back to the failover, let me just kind of show that one too, which I think is kind of cool. But first of all, let me see here. Let's take a look at it's on the inventory itself. So so I wanted to show you the circuit breaker thing, but I just realized it's so easy because there's a lot of moving parts to this course. Going from the Docker container down to running these individual services again, I completely forgot. If you look here, you can see like in the inventory application, you can see these errors right here talking about JMS. I completely forgot that we're using a Docker container that runs Artemis, which is kind of like, you know, for messaging, JMS messaging queue. So what I need to do is start that up. And the way I do that is I've got my trusty notes. So I started up Docker. As you can see again, I got the little Docker desktop icon right there. And I'm just going to go ahead and start this up. I'm going to stop all my services. Kind of wanted you to see this because it's kind of nice. You can basically stop. So now they're all finished, and I am going to be starting up the regular JMS message queue. And you know, messaging is very, very important. You've got Kafka, you got different ways of doing. The other course I finished in Node.js, it was a 50 some hours worth of videos. That one was using the NAT streaming service. I've used RabbitMQ. They all pretty much serve the same functionality. Artemis, ActiveMQ, it's another one right here. So I'm just basically starting up the configuration, or starting up the container, if you will. And as usual, I'm not going to show you all the details in here, but each of your individual services, you know, you'll set it up with a configuration, which is kind of nice. You know, you basically, in each of these individual projects, you'll see a configuration. Many of them have JMS config. Several of them have the local discovery configuration, saying, hey, when you're using this profile, we want to enable the local discovery client so that when the application boots up, it'll go ahead and send a, hey, I'm here to the Eureka service discovery thing. You know, these applications have, most all these are using, it's using JMS basically to send the messages, along with the Jackson serializer, deserializer for each of the messages that we send back and forth. So these have the individual queues, and you know, he goes into, you can bring up the you know, the queue application, the web-based interface to inspect and visualize each of these messages. I won't really go into that. But now that I have, you know, JMS up and running again, I can just go ahead and restart these services. And what you got to do is start up this first one you got to start up is Eureka, your service discovery. So as I start that up, you can see it's doing a build, and then it's going to start up the application. So I'm going to pause, and I'm just going to go through and start these up one by one, and then I'll resume this video when they're all up and running again. And actually, while I'm running the config server application, I did want to kind of mention another really cool thing about this course is he explains, you know, how you can dynamically, or you could have a central repository to manage and store your configurations. It's kind of like the parameter vault in AWS, where your applications can basically retrieve values from a protected key value store, if you will. So if you have sensitive information like your passwords, it's kind of like in Kubernetes, you know, how you could have basically the kind of like secrets per se. It's the same kind of concept, but you know, you can store your configuration values, shall we say, in a repository or any other type of source. But the idea about this application is each of these services, as they come online and stuff like that, you know, you're going to have this configuration service, which is going to manage all of that. So it's your basically it's your config server. So what happens right here is, you know, this is where you register with your service discovery application. So we're in our config server application. But here you can specify. So we're storing configuration information, you know, down right here in my own personal GitHub. So this is where I could store my properties like my name, my values, my password strings, connection strings, things of that nature. Now, actually, I was about to show you the configuration service, but I noticed I was getting an error starting up my gateway, API gateway, basically, because I had a lot of these services already Dockerized using my own Docker hub and pushing it up there. So I actually had another version of the gateway running in the container, which was causing a collision right here when I tried to start up this gateway right here. So thought I would just kind of show that a little bit. So let me just go ahead and start this up. I'm sorry that I'm all over the place, but that's the nature of these videos when you're making this up off the top of your head. So I'm going to restart that again. But let me kind of show you this whole thing about the configuration. So you have a, basically you can store your configuration parameters up in GitHub or any other place. So let me show you that. So I'm going to paste my repo right here, which my URL. And what you're looking at here is, you know, I'm going to have passwords in here, but they are totally bogus passwords. I do not use these passwords at all in any of my production or personal accounts. So, you know, totally insecure, just basically password. But imagine, if you will, this is totally protected in a private GitHub, which is secure behind a firewall or whatever it may be. So you store all of your parameters for each of your individual services. These are the ones that you actually want to, you know, basically protect. Also, he shows you, which is really cool, how to secure your individual passwords using Cypher. And there's another project, if you will, you know, another bomb thing that you can load. I haven't really talked about bomb yet. But anyways, that's kind of how you do it. Each of these individual services are going to have their parameters up in some centralized configuration place, so you can manage these configuration values somewhere. And then basically what happens is, you know, we have this, that's the whole purpose of this configuration server, is to pull that in and set it up. And based on, you know, based on that, here's your application name in the application properties file right there. For the individual applications out there that want to go ahead and get their parameters for those services, what they need to do is, like, we're in the order service right here. What they need to do basically is, if you go to your properties right here, you'll have, let's see right here, you'll have your Spring application name for these. If you notice, if we go back down to your configuration repo, not your repo, but your actual configuration service itself, if I can find it, there's a lot, config server, actually it's in your repo. These here, these directory names need to match the Spring application name. So if we take a look at the beer service itself, if I can find that, let's see here, where is it? Go back down to resources. You got your Spring application name right there. Those will match. So that's another Spring naming by convention thing that you have to do in your, you know, if you're going to use these configuration features right here. As you can see, we got our 3 directories. So one other thing here. So now if you're a client application, or if you're one of the microservices that wants to get the configuration services at runtime, what's really nice, and again, you'll see that there's a lot going on behind the scenes. If you go down, let's look at the beer service, for example. You go down into your resources, you're going to see a bootstrap local. So it's basically, it's another naming by convention. Bootstrap gets, Spring's going to take a look at it when it starts up the application for each individual service right there. So inside of here, this little magic trick right here, this is what basically says, hey, when I start up, I want to go ahead and ping the configuration. It's Spring Cloud, which is what we're using, by the way. I want to ping the configuration here, the discovery service, basically the discovery server for the configuration information. And oh, by the way, here's its name. It's MSSC brewery config, which basically is what this guy is registering right here, the configuration server. And so again, you know, it's got a, you know, it's got it, the Spring application name itself for each individual service has to match that directory in order for it to pull down the right one. So when it sees this, um, based on the configuration service, you know, it's pulling all this information down. I'm back in the config server again from the repo. And as other clients come online and their bootstrap basically is saying, hey, go over to the config server here by this name, and you know, here's my Spring application name, which is right here, beer service, go there and return me all the configuration information for this. That's all hardwired and done magically with the whole bootstrap thing like that. So again, one of the things that was a bit of a struggle when you're learning Spring, if you don't not familiar with it, there's a lot of magic happening behind the scenes. There's that whole concept of the invisible box. You know, it's not the easiest thing to trace procedurally the flow of control. You kind of have to know a lot of the conventions. But you know, I guess you know when somebody's completely up to speed in Spring, they can be very productive very fast, and you don't have to do as much code because then it becomes more of a templatized thing whenever you start new services and such. Anyhow, getting back to the whole failover thing, now that we've got things working again, I kind of wanted to show you, you know, sorry for the diversion there, but this is all good. Hopefully some people are actually getting something out of this and maybe, you know, willing to go ahead and buy the course, or because you'll learn a lot. There's another method right here. It's a REST API method that just basically says, given your beer ID, you know, show the inventory on hand, return, you know, the information about the beer plus how much you currently have on hand. Now, one thing about this application is it's using, so as you can see right here, we got a quantity in hand of 7182. There is a timer going off in this particular application, and it's done by using task.config. And what I mean by that, in the main beer service, when you start it up, this task.config, since it has a configuration annotation, again, that's another magic thing. So there you can specify, you know, things that get started, basically their configurations. So, you know, the bean generations will get generated at runtime, and so it'll basically start up, if you will, in Bootstrap. And so what happens is when the beer service starts up, it's going to do this, you know, simple async task generator. And what happens on startup of these individual services, there's a scheduled task. So this is a way of kind of simulating, like when you start up all the services. If you look right here, you know, we have the regular tasting room service, which is a part of the you know, beer service itself. And so what happens is every 2 seconds, it's going to, you know, randomly decide whether or not we want to place an order or not. So this do place order. So I just wanted you to know it is, you know, going out there and randomly through a timer, it's placing the orders. Plus there's another one that checks the inventory like every 5 seconds or something like here. But as you can see right here, this is like mock code. Ideally, you know, you would have like an API endpoint to place the order, and you would have a client front end that would do it. But again, there really is no front end with this particular course. So this is kind of like your simulated front end to go. And it's so basically it's just going to randomize order generation, which is why we're seeing all this data come up here, and which is why we're seeing activity scrolling here. So anyways, getting back to the circuit breaker, that's what I meant to do from the get-go. We got a quantity in hand. So what happens right now if our inventory application should die or stop or whatever? And that's what I'm simulating right here, is I'm bringing that down. What you noticed right here, if you notice subtly, that quantity on hand shifted from, you know, 79,000 or 7,900 or whatever back to 0. And that's the whole idea behind the circuit breaker pattern is, you know, when you go ahead and get the inventory, when you place, I should say, yeah, when you get the inventory, for this given beer and you want to see the inventory, you're getting the beer information, which is stored in one service, and behind the scenes, it's reaching out to the inventory service to get the total number of quantity, because that's the nature of these microservices. So you've got your repository to keep track of your beers and your orders, which is here, and then you've got another service that keeps track, given a beer, of the actual how much you have on hand. Well, if that service should die, rather than crash the whole, rather than crash this call and not return anything back, you still want to return as much back as you can. So our circuit breaker kicked in right now, and behind the scenes, that's returning a quantity on hand of 0. And the nice thing right now is, that's going to constantly return 0. Now, if I start up the inventory application again, so let's just say we simulated a crash and then we deployed a new version, the website, the application, and all that, all the other services can still function, and your site's running at about 80%, 90% capacity, and that's ideal in the microservice world. It's like when you go to an e-commerce site or an Amazon or whatever, you're going to have different tiles, different sections. Each of those may be serviced by a back-end microservice somewhere, and if any of those die, you don't want to prevent the user from seeing the whole page. Should the cart service fail, you still want to be able to browse for items and stuff like that. You just can't order them. So that's the whole purpose. You can kick these circuit breakers into play. Now, as you can see, I started this up again. Now it's going to take a little bit of time for it to kick in, but if you watch close here on the quantity on hand, it shifted back this time to 200, because honestly, we've got the whole in-memory thing going, but if I didn't have the in-memory flag on, it would resume back to what it was before, which was the 7192 or whatever. So this is still working. It's just the parameters on how I have this set up. Like when you start up a service, I've always got kind of like it's doing a recreated the schema of that inventory service. So it starts out with 200 again. That's totally configurable. I just basically, if I would have just set the startup mode to be update, then this would have started up at 7900 again. Taking a look at that circuit breaker then, so what that is all about, and it's fairly easy to set up. If we take a look at, I think it's in our gateway, and that's another pattern. You're going to have a gateway that basically services your client and redirects all the requests to the backend service, kind of like an ingress controller, if you will, in Kubernetes, or a load balancer in AWS. And it also uses aggregation. So you may have a request per se, if you will, that goes through your gateway, and behind the scenes it could reach out and call several microservices. But the gateway here using Spring, which is kind of cool, there is a way to set up your circuit breaker. So here we've got routes. And so I'm not really going to get in great detail about this, but right here you've got load balanced routes here. So this is where you set up your different paths and how they're going to be serviced. So like when people access the gateway with these URLs, it's basically URL-based routing. It's going to go ahead, these are the URIs. It's just going to reroute this traffic with these URLs to the beer service. Any traffic coming in that matches this URL pattern is going to be, basically going to the order service. Any URL based with these patterns is going to be going to the inventory service right here, if you look down here. And then there's an inventory failover. Now this is where this gets really cool. You can add a filter, and you actually have to install yet another kind of a package circuit breaker. So as you can see right here, and you can do this for all your services, but you can see right here, this is where we are basically tying up or making that connection to the failover, our circuit breaker. So it's a well-known, so this is actually coming from your circuit breaker filter factory. So if I go over here to the right, basically, and I take a look at, let's see here, the gateway. I was just right there. As a matter of fact, so you can see you can take a look at your plugins, but if you go to your dependencies right here, you can see that I pulled in, it's another package, Spring Cloud Starter, and it's a circuit breaker. So that's basically, and you can configure that, with different parameters. So I was just, using the defaults here as you go over here, but this is just another way that you can implement the circuit breaker pattern inside of Spring Boot. Another thing I haven't really gotten into, which I think is really, really cool, and I know this video is getting long, but if you're willing to hang on, you'll get a lot out of this course. Is they talk about BOM, bill of materials, and basically this is a way to set up each of your project's dependencies. So each one of these microservices has a, it's kind of like POM, if you will. So as you can see, as I was saying, each one of these services has a pom.xml file, and long and short of it is that is like a project object model, and it's basically it's a Maven related thing. We're not using Gradle in this particular project, but it's a Maven related thing, and it's unit of work, and it's like an XML file you're looking at right here that contains all the information about the project and configuration details, and it's needed to build the project. This is kind of like in .NET. It's kind of like your CS proj file per se, where you have your individual assemblies and dependencies that you're pulling in. But also, this gives you the ability to add packages with your dependencies. So this is kind of like similar to like in .NET projects where you would actually pull in like NuGet packages per se as well. So what I find really interesting is you can learn an awful lot about a project's structure and all the different packages that you're pulling in. And again, if you look here at this uh, you know, section here on the right, it's really, really cool. So a lot of this will actually show you what you've pulled in with your BOM, basically, and your POM, so that's project object model. But then there's, the whole concept of the BOM, which is your base. So what you can actually do, and he actually spends like a good part of the course, and you're going to learn a lot if you choose to do this, the bill of materials. The whole concept behind this, and it's a fairly significant section. The whole concept behind this is each of your POMs you can extend. You can extend many levels. You'll have a parent. So if you wanted to store centralized project information, which would be specific versions of packages, and you don't want to have individual projects out there using different versions of the same package and all that, you can manage all of that up in your parent configurations, and you can just require that, for all of your projects out there, that you extend from the parent. Now this, like for example, this doesn't look like it's really pulling in much. Let's see here. I'm looking at the beer order service. However, this little thing is the trick. This is actually stored out there in GitHub. So think of it for 1 second here. If you have an organization and you want to manage all the individual versions of your packages and stuff like that, and you don't want any of your developers to be accidentally using another version that may be obsolete or may be mismatched from what the rest of the company is using, you can say, hey, if you're going to use this particular dependency, extend from the parent, we'll manage all the versions and stuff for you. Just, plop this into your BOM, your POM files, and, import, refresh it, and you're good to go. All your dependencies get pulled in with the correct version. So if you ever wanted to do a company-wide distribution of another package or whatever, you can do it this way. Now let me show you something that's really cool about IntelliJ. Once you get all of your dependencies pulled in, you can right mouse click on the BOM itself, and then you can, basically go into Maven, and you can say show effective POM. And let's see here. That didn't, 1 second here. There we go. It just took a while. I was kind of pushing pushing the premature, hey, something's wrong button. But as you can see, I did the show effective POM. So what happened was this parent right here, by showing effective POM is pulling in everything. So this particular file of dependencies actually behind the scenes, when you pull everything in, is pulling all these individual dependencies and all their specific versions. So this is huge, as you can see right here. This is a big, big, long list. So imagine, if you will, this is stored somewhere centrally on a configuration server somewhere, managed by quality and control. Let's just say there's security patches, things you want to make sure you lock down, which DLLs or jars or whatever your organization's using. You can do it with this technique of parent bombs. And so all of these services pretty much follow that same pattern. If you look here, this is for the beer service. The project itself, you just got a couple of these parameter dependencies. These itself are specialized just to the service. But as you can see, let's see here, every one of these, you can always just turn around and do a, go to Maven, and you could just say, show your effective POM, and it'll just pull down and show you all of the stuff that you're pulling in, which is really, really nice. You can also, in each individual service, you can also take a look at your dependencies too. So under here, you can see these are all the different versions, and if you increase these, you can see the individual. So you can see what's going on here. You're drilling down a lot here. You can also see your plugin targets here if you want to run. So you can actually do your builds here as well. So hopefully that's a super, super high level overview of POM and bombs. And basically the course will give you a good walkthrough on that. Just a few more things. Spring Cloud Gateway, it's just basically a paradigm that allows you to generically have Spring configure your application such that it runs on site locally or in development mode, or you can run it on the cloud. And again, it's using convention by configuration. And of course, he goes over the API gateway pattern, which is something I'm familiar with. And hopefully you guys will get, if you're not familiar with it, it's definitely a common microservice pattern. Of course, there's service registration and discovery with Eureka. He goes over the circuit breaker pattern. A couple of other things that I wanted to show, and I thought this was really cool. I kind of talked about the MVC pattern in Project Lombok, what that was with the annotations, where it pulls in a lot of code. Let's see here. JMS, of course, we're using JMS. This one was a freebie, or actually this was a pleasant surprise for me, which was the Spring State Machine. Before getting into Sagas, which was like the real reason that I signed up and took this course, believe it or not, I ended up taking spending over 120 some hours doing all this Spring stuff that I didn't originally plan on doing, just so that I can get a much, much deeper grasp of Sagas and how they're used. This application is using the orchestration method of Sagas by utilizing the Spring State Machine. Now with Sagas, there's a coordination, there's ways to coordinate. You can actually have, your orchestration, where you actually have a central coordinator that just basically coordinates your transactions and which steps to take based on the life cycle of a transaction, all the way from start to completion, or rollback, if you will. That's one technique, is orchestration. The other is choreographed, which is, this application's not using choreographed. But anyways, what a Saga basically is in regular ACID-based terminology and transactions, when everything's lumped together in one process, it's fairly convenient to start a transaction, do a bunch of work, and then at any given point in that transaction, you can roll back, and it's basically going to undo everything. Kind of like in your databases, it's the same concept. Start your transaction, you can have many different levels of transactions with names, and you can roll back individual pieces like in the database. So you can kind of do something similar with these microservices. Um, when, but when it's a monolith, it's fairly easy to roll back your transactions. With microservices, on the other hand, not so easy. The whole concept of ACID-based transactions doesn't really exist anymore because, again, one of your logical transactions, like placing an order, can actually span several microservices, like as a transaction from the time the customer places the order to the time it, it checks for the inventory, from the time it fills the order, and from the time it packages and ships the order, and that also includes allocating your quantity in hand. That one logical transaction um, can span many different services, aka bounded context, and that's where the whole concept, the whole concept of sagas come in with microservices. And for me, I find it to be one of the most interesting and challenging aspects. I mean, there's all kinds of, you know, not all kinds, but there's write-ups. Saga's been around for since like 1987, the Saga pattern, but it's a way to do distributed transactions. Most importantly, rollbacks. At any given point, at any given point in the order process, your transaction can be in a pending state, a holding state. You could have some services that are down that aren't able to complete the transaction, so it'll have to resume at a later time or try to resume. Um, you're going to need a way to roll back, and that's usually done. Rollbacks are done with a kind of a concept called compensating transactions. So a compensating transaction, or a compensating event, if you will, um, that just basically undoes your transaction, or it undoes all like the steps so that your transaction is back to the null state again. You haven't lost any history. You're not really rolling back things in the way you would do in a database or in the regular traditional aspect. You're still going to have a record that you tried to do the order, and you're going to be able to see that it failed. But the whole purpose is, depending on the transaction, what you're trying to do, if you can't continue on anymore for whatever reason, you don't have inventory, the item's back ordered, it's no longer in stock, it's discontinued or whatever, you're going to want to give that inventory back to, or you're going to want to also maybe refund the customer their money or undo their pending state of their order, send them out an email or whatever. All of those kinds of actions are what would make up your compensating transactions. So that's the whole purpose of sagas, is defining that. And uh, don't feel bad, because sagas can take quite a long time to understand and to do them right. There is no real easy answer with the saga. And they're out on Safari, on YouTube, there's if you go to some of the microservices, conventions and things like that, I mean, people give speeches just on sagas alone. So this course does a really good job, I felt, explaining, the need for sagas. I kind of mentioned that because a transaction can span multiple services, and you're going to need a way to track that down in each step. And also the other thing with microservices, and I might do it as another video here, is distributed tracing and logging becomes extremely important with microservices, because your transactions are going to span multiple services. And if you have a problem with an order, you're going to want to actually see potentially where the problem occurred. And that's where your distributed tracing comes into place and stuff like that. So the Saga Coordination, there's that whole issue of orchestration, sagas as opposed to choreographed. I didn't really get into defining those two again, but let me kind of mention, first of all, Transactions in microservices follow the concept of eventual consistency, meaning you're not going to block. Everything's asynchronous. And if you place an order, you don't want to block and wait for the order to be completed, because you could be waiting for, in the real world, you could be waiting for days before the order completes. So that's where the whole concept of eventual consistency comes into place is, hey, I'm placing an order right now asynchronously, and I'm going to fire off all the necessary, I'm going to fire off the initial event, which behind the scenes is going to communicate that to whatever other microservices need to know about it. And it's going to start that transaction rolling. Now that transaction could stay at rest for a while until it completes. That's what eventual consistency means. Now, eventual consistency can end up in a positive or a not so positive state, but in either way, your transaction completes, whether it's through a compensating transaction or whether it goes all the way through back to its consistent state again. So with the orchestration, I'm kind of taking a look at like some of my notes and my flowcharts here on this application. There's two types. There's the orchestration way of coordinating your sagas, and that's where you have a centralized decision maker, and that's what this application does, and it's using Spring State Machine, which I found to be really, really cool. I'd done a bit of stuff in the past with telephony, computer telephony, predictive dialer, that kind of stuff where we use state machines. So this is right up my alley. And if you like state events, driven state machines and all that, you're going to like this course because they walk you through how to use a good package from Spring, for the Spring State Machine. And then there's also the choreographed, way of coordinating your transactions. And that's choreographed is a little bit harder to follow from start to finish. Choreographed basically is where you have each individual actor, if you will, within the transaction deciding which next step to take. So you don't have a centralized coordinator. When with the orchestration one, you have just one common source of truth. Now there's advantages, there's benefits and pros and cons for each one. The choreographed is, your transactions, your individual steps, if you will, are loosely coupled, and they're pretty much simpler as a general rule of thumb. They're good for simpler sagas, but they are harder to understand because your logic is spread out all over the place. With the orchestrated one, which is what we're going into right here, the benefits to that, it's easier to follow, but the cons of that is a single point of failure with your coordinator. Should your coordinator go down, you're kind of in trouble. But again, in the environment of load balancing and distribution, load balance and redundancy and things of that nature, we're saving the states to the database as we go from step to step. So that'll kind of protect you in that case. Getting to the next key point, and I'm so sorry that I'm rambling on here, but this kind of stuff is exciting. Let me show you a little bit about the Spring State Machine. So as I was talking about with state machines right here, he helps follow the trace of an order from start to complete. And so if you go to the order service, now this is really, I found this to be really handy using the the orchestration thing, if you will. In the order service, there is a state machine package that we create, and I spent quite a bit of time drawing these states from start to complete. And he goes over this in good detail too. But there's a state machine, and we're using basically the Spring State Machine package. So if I go here to Maven and I take a look at the order service, go to dependencies, let's see here. If you look right there, you've got your state machine core right here. So let me just quickly show you in a nutshell what this is doing. And, I'm not going to go into great detail, but this is where you configure your states. So there's a class called the beer order state machine configuration. Let me just minimize this. And again, it's these are annotations. Again, Spring is all about annotations. So if you highlight this, you can take a look. You can see the package that it's coming from. So when you import all these different packages, think of it kind of like when you're in NuGet packages in .NET. Um, the documentation and such for each of these individual features you want to pull in, they'll have good documentation on which decorators and stuff that you need to do, along with the rules. Like here, you've got enable state machine factory, which has, you know, these different types of policies that you can override. So there's an awful lot going on there. But getting back to the config, so here's the other thing too. This required args constructor, again, it's a part of Project Lombok. Again, you get used to this with Spring. You'll be like, hey, these variables are declared as final, but I don't see where they're passed in. So again, it's all about the magic of these annotations and decorations with Spring. This required args constructor, you know, it just basically says find all your final fields in your class and create behind the scenes a constructor where this gets injected in at, you know, at compile time. It actually at compile time, but it's injecting it at runtime. But at compile time, it's like generating the constructor itself that takes these parameters in. So it's doing a lot of plumbing. So Spring is all about the plumbing, all about, now it's not all about, it's a huge part of it. And it's about saving people's time, but it comes at kind of an expectation and initial cost of getting up to speed in it. And again, in no way, shape, or form, even though this course says beginner to guru, in no way, shape, or form do I even consider myself to be remotely a guru. At best, I would consider myself a novice, but now having taken this course and spending, you know, a better part of a whole month, pretty solid, over 120 hours or whatever you want to call it, I would say I have enough knowledge to be able to start taking a look at Spring-based applications and understanding what's going on and knowing where to go and where to look. You know, if I ever get the opportunity or fortune to be hired or whatever. But getting back to the state machine, you know, there's rules here. So I'm not going to get into detail right here, but, you know, with your state machine, you'll define your new states, your initial state, I should say. And then basically you'll say, you know, here's all the states I want to handle with the state machine. And then these are all the individual end states that basically say a transaction is complete. So you can have many one of these. And then in between, this is all customized with each individual type of transaction that you want to do. Again, this is a Saga coordinator, and the coordination's happening via a state machine. So you define your initial state, and then your end states, and then all the individual states you want to support. So if I go to the enumeration here, you can see these are all the individual states that we have. And then you get to the heart and bones of it. This is kind of where you flow chart it. Now I spent quite a bit of time, and I might include a screenshot of it because I drew it on paper and mapped it out with columns saying, you know, here's your start state, here's the event that comes in, and this is the particular type of transition that you can do. So right here, this is just basically a typical state machine. You know, you've got your start state, and then you've got your end state. And in order to get from this start state right here to this end state, this particular event will come in. So you've got your, you know, again, each one of these, you've got your start and end state, and then you've got your event that will transition you from your start to your end state. Now, what's really cool, remember how we were saying coordination is a single point of failure when you're coordinating sagas? One way around protecting that single point of failure, and I think it's really cool with the Spring State Machine, is you can hook up actions to each of these too. So the idea behind an action and what we're doing here, with actions, not just actions, but also interceptors. But let's take a look at the actions. So each of these are your actions. So it takes your state and the event that comes in, and then you can actually like call these. So if you take a look at this validate order action, for example, again, Spring is doing the whole naming by convention. So these particular actions right here, you'll declare a package up here called actions, and you don't have to actually call the package, it's a directory or package itself actions. But the main important thing is your individual actions have this naming convention where if you specify it this way here, like validation with the lowercase, it's going to actually look for a package name that has, the same class name as your action name. And that's just basically what Spring State Machine is going to do. And then it's going to execute your actions. So what you're looking at here is you're looking at these individual actions on the individual events. So if I take a look at the validate order action, it's going to call this. It's going to call this execute method right here too. So if you take a look at the, you can take a look at the action interface right here. It's got an execute which takes your state context, and so this execute gets called, and what's happening is this is where you would do some of your business logic behind the scenes. So like in this case for the validate, we're just basically trying to make sure that, reaching back over to the beer service, we're going across service boundaries again, because we're doing this in the order service. And we're just basically saying, hey, is this a valid UPC ID and stuff like that? And based on that information, it's sending the request through JMS over through to the JMS order queue. And again, I have the JMS service running right here. And there's also a UI for JMS that you can look and inspect all of your messages, just like with your RabbitMQ. So this is where we're actually converting. So I just wanted to see your individual actions right here. If anything, you could just log these. This will give you an opportunity to log the individual things you're doing. The deallocate is for the compensating transaction part of the Saga. When something goes wrong, we're giving the inventory back to the inventory service, basically. And that's what's happening right here. This deallocate order queue is being listened over on the inventory service. So I know I'm kind of jumping all over the place, but that's just the nature of like a code walkthrough. So if you take a look at your inventory service, you've got your JMS config. So see this deallocate order queue, I'm back in the inventory service. And, this just basically is saying that, we're going to be listening for these given events. As you look here, we've got, a deallocation service, and we got a deallocation order listener, which is listening onto that queue. And based on that event coming back, the inventory service itself is giving that inventory back. So I know I jumped all over the place here, but it's important to know that the action in one service from the state machine, is turning around and passing a message. That's a common convention of microservices, is you'll pass a message from one service over to another, and then the other service is going to do what it needs to do to its own database. And again, each of these individual services have their own database. So in the beer inventory, it's, the deallocate basically is going to go ahead and give that quantity on hand back to the inventory, for that given beer ID. So that's kind of in a nutshell what's going on here. So if we go back to our order allocation action, which is inside of our order again, we want to do a close others, and then go back to our state machine. I wanted to get into another really important concept. In order to handle that single point of failure, you have what is known as a state change interceptor that you can do also, and it's a part of the state machine package, which I find really cool. So for anybody that's done like Angular or jQuery in the front end, you have the whole concept, you know, you can use HTTP interceptors, or you can use like an Ajax, $ Ajax. You can add request interceptors, which is like a common, it's a way, it's kind of like aspect oriented in the nature where you are injecting decorating behavior on, it's using a decorator pattern, but it's basically without one class knowing about it, another, shall we say, capability is able to attach itself or, you know, intercept traffic going back and forth or events. So what we ended up doing with this state machine configuration is we have interceptors, which basically is attached to the state machine too. And I find this really cool. But what happens in these, you know, these interceptors is this is where we have a way to persist the transitions as they occur. So again, with these interceptors, you can, you know, you can opt in to say, before the state changes itself, anytime there's a transition into the state machine, I want you to call this interceptor. And what the interceptor basically is going to do for the order is it's going to take that current state coming in right here, and it's going to save it to the database. And so if we take a look at the, like the order service, if you see here in the order service itself, we've got this order status column down right here. And if we take a look, you know, just randomly do a select from that table, you've got this order status. So these numbers map back to the enumerated data types of the, let's see, the statuses right here. So if you take a look at the status enum, so this is that enum, and these values here are what maps to this order status. So what's happening is anytime you transition from one state to another, before you do the service and stuff like that, before the state actually changes, you know, it's going to persist that to the database. And we do that through the interceptor. So this is just another hook. Set the order status and then flush it right away. And how you wire that up, that basically, this interceptor right here, if we do a find all references, let's see here. We've got our private final. Let's see here. I'm trying to, there we go. So in the beer order manager implementation, which is a part of the order service, so I'm still in this order service, and this is all about the Saga. When you configure your state machine, basically you're building your state machine. At the time you build your state machine, this gives you the opportunity to add things to it. So it's very similar to your configure services in .NET Core, where you can attach behavior inside of your pipeline per se. You know, you can attach and add more and more behavior, you know, as a part of your request pipeline. That's kind of what we're doing here, is we're attaching a state machine, add state machine interceptor. It's actually, it's a legitimate, you know, piece that's coming from the state machine core package, as you can see right there. So I didn't write it, but it just basically allows you to, you know, add some of these additional features. But that's how we handle the single point of failure thing, is by attaching an interceptor. Anytime this particular service goes down and we start it back up again or whatever, we can resume right where we left off before, because we've kept track of our state. It's not in memory. It's being persisted to the database. So I hope that, excuse me. So I hope that helps a little bit. So, you know, basically there's logic that when you're persisting back from the database, you have to reset your state machine by building. But if you look here, you can see all the individual methods right inside of here, which, you know, it's a part of the order manager implementation here. So, you know, this is like the different events we're creating. These are like, this is what you do when you want to create a new order. and you're sending these events from, you're sending these out through JMS. You got your send beer order event. Here's basically when you transition from one state to another, whatever. If you look right here, we're like in the send beer order event, we're building the state machine from that beer order, and then we're actually sending the event itself here to the state machine, which ends up having the state machine configuration call the appropriate action, as well as the interceptor right there too. So the action itself is going to send JMS messages from one microservice to the other. But it's key to know that there's a common pattern you follow, is that you can, through the state machine factory with each of these events here, you're going to build your state machine. Like here's the beer order pickup. Let's see here, you got your send beer order event, and your send beer order event. You're going to actually, here's your event coming in from that enum, and then here's the beer order. You're just basically going to construct your state machine object right here from that beer order. You're going to create a message, and then you're going to go ahead and set the order ID header, and then you're going to build it. And this send event right here is actually sending an event directly into the state machine, which let me get back here, go back to the state machine. It's going to send it into the state machine, and we've configured it such that based on, this is that event. These are the individual events that you're sending in. Based on that, it's going to take a look, or your state machine class is going to take a look at your source state, and it's going to call your events and your target states to transition it to, and it'll call these actions in the interim, basically, that you have defined up here. And we kind of went, kind of explained a little bit about the actions and what they do. But the actions, are going to allow you to do more of the business logic, update the database, potentially send out a JMS message to another microservice and all that. So don't get confused with state machine send event and action send messages, because the actions themselves are going to use JMS to send the messages to other microservices. But in the state machine, when it calls the, let's see here, the send event, bear with me 1 second here. When you're implementing the actual part right here, the send beer order event, this is actually invoking the state machine to call the appropriate actions. So you may be asking, at what point and stuff like that do these get called? So in the implementation, let's see right here. If you look here on the new beer order event here on this beer order manager impl, let's see here. These will actually get called from our controllers. Our controllers ultimately are going to call place order right here. So, like I said, the place order will be invoked from, actually this would actually be a client operation right here, but you'll have like list orders for the most part. So that's going to actually get called from a REST API call. Here's your beer order controller. So this is what the outside world would call into based on a GET mapping, and there's your URL path. For anybody that's done .NET, you'll know that these map to your HTTP GET and your HTTP POST with the URL or the routing endpoints, if you will. But behind the scenes, this is following a common pattern, like the unit of work pattern, but it's calling the service down here to list the order. And if you look at the actual implementation of the list order, it ends up, doing a lot of the logic inside of there. And ultimately returns a response back to the client. But down here on the place order, that was kind of a bad example up here, but the place order is actually going to go and cause a transition to occur. So as you can see right here, the place order gets called, it'll get called from the REST endpoint. And then behind the scenes, it's getting the incoming beer order DTO from the customer, as well as the customer that made the request. And then it ends up calling new beer order on the manager's implementation class. So when you look at the new beer order, that's when it shoves the event basically down into the state machine. And so here's where it's actually shoving the beer order DTO, if you will, into the state machine. And this is where it's performing the transaction. And keep in mind, behind the scenes, based on the configuration of the state machine, based on what its current state is, this is actually what's sending causing the state machine to actually do something, the send event. You know, it's going to examine, based on the event coming in, it's going to examine your, shall we say, it's going to examine your current state, and then it's going to call the appropriate action itself. And that's where you have the opportunity to execute your actions and then do whatever else you need to do inside of here. So do keep in mind that here's another key piece of information that's not intuitively obvious. You may be wondering, and I wondered the same thing initially, you may be wondering, why not have your actions themselves do the actual transition to the next state? You know, why have this target state right here? Because keep in mind, this targets your next state change. So the state machine library itself, when you're done, when you call that send message or that send event, when you're done, it's actually going to transition to your target. And again, it's another state change. So guess what happens? That's when your state change interceptor gets called, and then it's going to update the database with your new state. So, but you might be asking, how come you don't have your action doing that? Let me get back to this. How come you don't have your action actually doing the transition? Well, if you look here, the event itself is taking, you know, an action. I'm sorry. The action itself is taking a function, you know, it's an action, and it's basically going to call execute on it. So if you look at the any of these actions right here, it's got an execute method. Well, guess what? That execute returns void. So there's no way to, I mean, you don't really want to, you don't necessarily want to do your transition or set your transition here. You just want to do your action, do whatever it is, and then let the state machine itself, when it's done calling that, let the state machine itself set the next state for you. And again, by doing this target. And again, by having it do that, it's going to go ahead and call this interceptor, since we have that wired up, and it's going to update the state appropriately in the database. So it's just kind of a cleaner, single responsibility pattern kind of a deal. And I actually think they made a good choice when they did that. To understand Sagas and to understand Spring Boot microservices and all that, you don't really need to know or understand the state machine class, you know, but I found, and I was really glad that the instructor went over this, and I kind of have a feeling that's probably one of the big reasons why he chose to use the Spring state machine, or why he chose to use orchestration instead of choreographed sagas, is so that he could demonstrate this very, very powerful library. So, and then the other thing too is you have the concept of compensating transactions. So if you go back into your state machine, you can have many cases where you have the same source state. Like here's an example. We got a validated state right here, and then we've got a validated state right here. But we have two separate events that are coming in. So we will have an allocate order event, and then we'll have a cancel order event. Again, this is business logic, and you set this up whenever you're declaring like a saga or transaction. You'll set up all your events, and then here's your target. So you'll have like a canceled, and then you'll have a pending. So there really is no notion like with this. There is no true identifier that says this is a compensating transaction. A compensating transaction is just kind of like a logical construct on it. There are other Saga frameworks out there, like there's one in .NET where you can actually specify specifically your compensating transactions. But here, the way this course is attaching or allocating, or addressing the sagas, I should say, with the compensating transactions. It's just treating that as another end state with like a failure, and it's calling an action like validating failure action, or like in the allocate order, like in the cancel order. Uh, if you want to take a look at, let's take a look here at the cancel order. There is a case when we cancel an order after we've already allocated. Here we go. So here's an event, cancel order. There's no action to this one because we still haven't allocated it yet. So there's a cancel order event that can come in. Here's another case where you validated it, but you cancel it, but you haven't allocated the order yet. Here is another state where you actually have allocated, so you've told the inventory service to hold on to that, reserve that, quantity for you. But in the case where you've done that and you cancel the order, you actually want to go ahead and deallocate that order. And so that's why in that particular case, you're actually calling the deallocate order action. And that's where this sends out that JMS message over to the inventory service to give that inventory back. And notice here's that map struct thing again, where we're taking, we're translating our incoming beer order, which is our entity object, and we're translating it back over to order DTO, which can be sent out over the wire through JMS, over through ActiveMQ, on over to the inventory service to process that order. So I know that was a mouthful. I think I'm trying to see if there's anything else. There's some really cool stuff too. I mean, he gets into the integration testing. I particularly like the whole concept of the Spring Cloud Gateway and the service registration. I showed you a little bit about that, and then I showed you about the circuit breaker pattern. The distributed tracing, I may do another video on that, because that's where you use Elasticsearch and Kibana. Like I said, I may do another video, but I think I'm going to stop on this one because I think I've really went way, way longer than I really wanted to. Would I recommend this course? Absolutely. I may never get an opportunity. I'm not partial to one technology over another. I'm not married to .NET. I'm not married to Java or Python. I like them all, and I'd be willing to do them all, or one or the other in any given job or a situation, because microservices is microservices. It doesn't matter really what language they're in, and I just really enjoy the domain-driven design aspect of it, and being able to deconstruct a monolith and identify the stores. And we can use patterns like the strangler pattern, which I may get into in the future too. But I'm probably going to stop right here, and then in another video, what I'm probably going to do is, bring this whole thing up in a Docker environment and kind of get into that. Because right now, if you remember, I know this is long-winded, I've got everything started up right now as individual standalone services, where you can see right here, but I didn't really get into the Docker part, and I'm probably going to do that, in another video pretty soon, and I'll probably end up putting in here. So thanks for watching this. I hope you learned at least something from a very, very high level. I didn't attempt to really do deep dive on this, but I just kind of wanted to give you a feel for what this course offers. Be prepared to spend a lot of time with it. And it's time well worth if you really want to learn about microservices, particularly with Spring. Again, my main motivation for doing it was to see how they address the whole Saga pattern. And along that journey, I got introduced to all kinds of other pleasant surprises. So I kind of got myself reacclimated again with JMS, because I had done JMS in the past. I kind of got reacclimated with a few things. with Java, and IntelliJ. So plus you get the 4-month subscription that the instructor gives you, and he's really nice instructor. They answer your questions in a timely manner. Um, I will admit there are times where things I was struggling, things didn't start up, and I did have to make a couple of changes here and there, and you'll probably encounter some of the same situations, but um, that's where you have the opportunity to bug and troubleshoot and continue to learn more. And take your time with this course. I feel that you will be rewarded. So I'm going to stop this right here, and then eventually, hopefully soon, put another video on the whole Docker Compose. I didn't do the Kubernetes part. I'm sorry, I didn't do the Docker Swarm part because I do the Kubernetes. I might, if time permitting, I may go ahead and put all this stuff into a Kubernetes cluster and spin it up like I did for another course in .NET Microservices in the past. I worked with the instructor on that one. So again, thank you for watching this, and I hope again you learned a little bit. So, and you have yourself a good one, and take care. Bye-bye.